Hey guys, welcome to part B. We're continuing with proportional relationships. To start this off, I gave you two tables that were slightly trickier because they both look proportional, but actually only one of them is. So if you were looking for a pattern in these tables going down, you might think that both tables were proportional because going down on this column is constant, right? It's always going down by +1, and over here, it's always going down by +3. And then you look at team D, and you try to find like a problem in the pattern, but it looks like it's still constant. This one, the time is always changing by 1 hour, and the distance is always changing by 2 miles. All right, but there's one key difference. And the difference is when you look for a connection between the two variables, like going from left to right, team C works out because you can multiply the time by 3 each time, and that will always give you the distance. Meanwhile, over here, if you try to look for a pattern involving multiplication, you can't do it because first of all, you can't multiply 0 by something to get 4. 1 times 6 would be 6, but then 2 times 4 would be 8. So there's not a proportional relationship here. So if you were going to explain it, you would say team C, and then kind of in your own words, how there's a constant pattern in team C that relates the time and the distance, but there isn't one for team D. All right, and then part B says graph this relationship. So remember that proportional relationships, they're very easy to identify. You can notice them what they look like, not just in a table, but also in an equation and in a graph. So we need to graph these two relationships, and when we do that, we're going to be reminded of what a proportional relationship looks like and what it doesn't look like. So raise this up a little bit. Quick review on graphing. So when you have a table, typically the first column is your x value and your second column is your y value. And we're graphing ordered pairs is their technical term. You could also call them just a point or coordinates. That would be fine. So the first ordered pair is 0, 0. The next ordered pair is 1, 3, and kind of so on, like that. So that's how we're going to graph it. So the first ordered pair is 0, 0. So that one is just right here. And remember, that's called the origin, the point of 0, 0. The next point is 1, 3, or 1 hour and 3 miles. So we'd come over to our x value 1, which is right here, and then go up to 3, and that would be the point 1, 3. The next one is 2, 6, or 2 hours in 6 miles. And I'm going to go ahead and graph the rest of this. If you haven't, pause it and then check your values. You should end up with points that look like this. And typically, when you're asked to graph something like this, you imagine that the relationship is continuous and goes on forever. So you kind of want to show that in both of them. Okay, and now, how is the proportional graph different from the non-proportional graph? All right, so if you remember what makes what proportional relationships look like on a graph, first, they form a straight line because their change is constant. And so if you only remembered that, you might look at these and be like, well, wait, they're both proportional. But do you remember the second thing that's true of a proportional graph? It's only true in this one and not true in this one. And it is the fact that this one starts from the origin, right? Proportional relationships are always going to have 0, 0. So they should always start or eventually pass through 0, 0. And this one doesn't. And if you really think about it, the reason why is that if you take this point and you try to multiply the x value by something, there's no number that would work to make 0 times something equal to 4. Whereas this proportional relationship has 0, 0. It doesn't matter what the unit rate is. 0 times anything is going to be 0. So that's kind of like a deeper reason why. But so how is the proportional graph different? Well, it starts from the origin. That's the main reason. All right, this one is kind of tricky, and I'm very curious to see who figured it out on their own. So it says, last summer, a family took a trip to a beach that was about 200 miles away from their home. The graph below shows the distance driven in miles and the time in hours taken for the trip. So looking at the graph and just sort of thinking about it, we have the hours as their x value. Remember, that's the first value in the ordered pair. And then we have miles as our y value. All right, so for example, if we just looked at a random point, the 6 200 means after 6 hours, the family had driven a total of 200 miles. Okay, now the actual question. What was their average speed from hour 1 to hour 4? Alright, so let's look at those two. So hour 1, we see that they've already gone 50 miles. And then in hour 4, they've gone 150 miles. So the way to calculate average speed, and I'm kind of wondering how many of you have seen this, is basically to think about the change in distance divided by the change in time. All right, so let's think about it. At hour 1, they've already gone 50 miles, right? And then by hour 4, they've gone 150. So how many miles have they gone from 1 hour to 4 hours? Well, they went from 50 up to 150. That's a change of 100 miles. So in those 3 hours from hour 1 to hour 4, they traveled 100 miles. Now let's think about how much time that was. Well, it's not 4 hours because we're not starting from 0. We're saying starting from hour 1, how much time has passed from hour 1 to hour 4. So from hour 1 to hour 4, that's a change of 3 hours. So basically, in those 3 hours, they went 100 miles. And if we divide those two, we're going to figure out their average speed. So 100 divided by 3, if I were to start trying to do that, 3 doesn't go into 1, but it goes into 10 3 times. Same thing. And then this would kind of go on forever. You'd keep getting a remainder. And it would kind of look like this if you sort of kept it going. But if I take a look over my answer choices, I see that 25 miles per hour doesn't make sense. I definitely know it wasn't 100 miles per hour because it was 100 miles in 3 hours. 66 miles per hour is too fast. Basically, they had to have gone about 33 1/3 miles per hour. That's the only answer that really makes sense in this situation. All right. Well, I'm kind of wondering if you figured it out, if you thought about it the way that I did it, or if you kind of came up with your own way to think about it. The nice thing about state test multiple choice questions is sometimes you can just look at the answers and only one of them is going to make sense. So if you weren't sure about any of this, you could have just started here and thought, okay, we got 3 hours from 1 hour to 4 hours, And if they went about 33 each time, you'd get 50, and then you'd have to add another 33, and you'd get 83, and then you'd add another hour, which would be like 116, and then add another one, and you get like 149. So that's 3 hours, and oh, that's really close to 150, so it has to be that. Lots of ways to figure these out. Really look at your answer choices and see which ones make sense and which ones don't really make a lot of sense. Alright, so did you learn something when you watched this video? Well then, good for you, nerd.